Okay, let us see how we can solve this very problem. Let us see how we can find the value of T1 and T2. Meaning to resolve this system, we need to consider static equilibrium. You know that for static equilibrium, there are two conditions that must be fulfilled. It means that we must fulfill two conditions under the static equilibrium because this one is a case of static equilibrium. It means that the first condition is that the net force must be zero, and also the sum of the torque must also be zero. Now, for this system, we are not dealing with the case of torque. Please take note, we are not dealing with torque, and the torque now has to do with rotational equilibrium, which is this very condition. But for this system, we are going to use component to resolve it. Therefore, it means that this very one, the torque, is out of place. Meaning we are not dealing with rotational equilibrium, we are dealing with translational equilibrium. Because for this system, we are going to use a component to resolve this very system. Now, I'll have to now resolve this very system into component. I will bring out my S components. I'll bring out my S components, okay? I'll bring out my S components and also my Y components. Also my Y component, the same way here. I'll also bring out my X component. I'll also bring out my Y components, okay? You can see now that we already have the components in this system. It means that for this one, I will have the weight force, you know, it's downward and it's equal mg. Please don't forget that. Okay, don't forget that we have two tensions, T1 and T2. It means that this one is a rope and there is a tension force here. This one is also a rope and there is a tension force here. It means that for this very one, the T1, means for this very one it will have effect here. This one will also have effect here. The same applies to T2. We also have effect here. We also have effect here. Now, how can we now solve this very system properly? Meaning, I need to complete this system so that I can solve it better. I can solve it better. Now, in this situation, it means that if here is 40, here will be 40, here will also be 40, and if here is 50, here will also be 50. Alternate angles. Alternate angles. When you look at this position here, it's a Z angle. And Z angles are alternate angles, and they are simply equal. They are simply what? Equal. Z angle. Look at it. Z angle. It's forming Z there. The same thing applies to this one. This one is forming this very one. Look at it. This one is forming this very one here. Forming this very one here. You can see the position of this very one. I mean, here is 50. It means that the other one will also be 50. You can see there. You can see this one. We refer this very angle, alternate angle, as Z angle, and they are simply alternate angles. Okay, let us see now. Please don't forget, before I told you that T1 has effect here. Here becomes T1 sine 40 degree, and here we go T1 cos 40 degree. And why here is T2, because this T2 will also have effect on both compound, both houses. It becomes T2 cos 50 degree, and this one here. This one here will also be T2 sine 50 degree. T2 sine 50 degree. Okay. Now we now have a complete system now, meaning we can now solve better. We can now solve better. Now to resolve this very system, we need to now consider the case of net force. Please don't forget, I told you before that this one we are using the components to resolve it. We are using components to resolve it, which of course is the net force is equal 0. It means that the sum of forces in the S direction is 0, and also the sum of forces in the Y direction is also 0. Okay, let us see what we need to do here. Okay, looking at the first one, which is the sum of the forces now in the X direction. And which one are X there? Which one are X? This one is X, this one is S. And the first one here, which is this one, T1 cos 40 degrees positive, means T1 cos 40 degree. Okay, this one is negative at the arrow head, pointing to the left, while this one was pointing to the right. This one was positive. This one was positive. Why this one is negative? Okay, it means that here is T1 cos 50 degree. Okay? If we are okay there. Yes. Meaning we can now move on. Please, you can see that the net force is 0. It means that some of the forces in the S is 0, some of the forces in the Y is 0. It means that for this one will be 0, become T1 cos 40 degree minus T1 cos 50. Okay, please, this one was T2. This one was T2, and this one was T2. Please take notes, look at it. This one was T2. Okay, now we can now move on and make one of them the subjects. I can make one of them the subject. Okay, let me make this one. Let me carry T2 over. T2 cos 50 degree. T2 cos 50 degree. Let me carry it over. If I carry it over before T2 cos 50 degree equal T1 cos 40 degree. Now, what can we do here? We need to now make the T2 the subject of the formula. It means that we divide both sides by cos 50 degree. Become T2 equal T1 cos 40 degree all over cos 50 degree. Cos 50 degree. Okay, let us now see what it will give us there. The value it will give us. Meaning we need to now divide cos 40 by cos 50, and at the end we are going to have 1.1918. It means that in this case now we have T2 equal T1. Okay, that is to say, if I divide this one, it will be 1.191818 T1. Okay, this one will be equation 1. Let me make down equation 1. Let me make down equation 1. Okay, since we have been able to obtain the T2 now, let us now see how we can. Okay, we have resolved the horizontal component. Let us now look at the one that has to do with the y component, which is this very one here. It means that sigma Fy, let us see the one that are vertical. This one is vertical, this one is vertical, this one is vertical. Okay, for this one is positive, that T1 sine 40 degree. Okay, plus this one is positive, this one is also positive. This one is T2 sine 50 degree. Okay, and this one is downward. You can see the weak force minus W. Okay, now what can we now really do here? It means that this one is 0 equal T1 sine 40 degree. Okay, and we have T2 sine 50 degree minus W. Okay, now what can we now do again here? I need to now make one of them subjects. Let me take this one over. If I take it over, I will have W equal T1 sine 40 degree plus T2 sine 50 degree. Okay, now we can substitute the one of the W and it becomes mg equal T1 sine 40 degree plus T2 sine 50 degree. Okay, now what can we do? Let us now substitute properly. We have mass and we also have G. Don't forget G is 9.8. G is 9.8 meter per second square. That is the value for G and it is constant. While for the mass, we have 80 kg. Mean that here is 80, okay? Times what now? We have 9.8 equal T1. And what is sine 40 degree? Look at sine 40 degree, and what we have here is 0.6428. That one is sine 40 degree. Okay, now look for, okay, I think we can as well substitute this very one here. Okay, let me just leave this one first. Let me leave it first. Become sine 40 degree. Let me substitute this very one. And this very one here, what do we have? Look at it here from equation 1. Look at it there. From equation 1, please I have to make this one equation 2. Let me make this one equation 2. In this one here, equation 2. Okay? It means that from equation 1, I can substitute this very one here. This very one. I will have this, which is a 1.1918 T1 sine 50 degree, T1 sine 50 degree. Okay, now we can now move on now. Let us multiply. As you see, 80 times 9.80 times 9.8 have 784. 80 times 9.8784. And what is the sign of 40? And we have 0.6428 T1, okay, and when you multiply this one, 1.1918 times sine 50 degree, okay, we have 0.9129. Here is 0.9129 T1. Okay, that's what we have there. Meaning, I just go direct sine 50 degree multiplied by 1.1918. Okay, now from there, now we have a common terms now. On the right hand side, we have a common terms, like terms. Therefore, we can add it. We can add these two terms there. And when you add it, we are going to have, okay, we are going to be having here, we are going to have 1.5557 T1. This is what we have when we had the other side to the right hand side. Okay, because those two things there, they are common terms. Now I can divide now by the coefficient of T1. I can divide by coefficient of T1. I will have T1 equals 784 divide 1.5557. Okay, and when I divide that, I'm going to have 503.95. 503.95 Newton. 0.95 Newton. You know we are dealing with tension. You know the unit for tension is Newton because it also deals with force. Because tension is also a force. It exists in a rope. Tension exists in a rope. Okay, now we have found the one of T1. I think we cannot look for the one of T2. We can calculate for the one of T2. Now to get the T2, I have to move to equation 1. I have to report your mind to equation 1. Let us now move to equation 1. And the equation 1 is T2 equal 1.1918 T1. And we are able to obtain the value for T1. It means that T2 now is now equal 503. Okay, let me take this one here. 1.198. Okay, T1 now, you know, there is a multiplication sign connecting both of them here. It means that it is times. Okay, times 5. The value of T1 is this. That is 503.95. Okay, multiplying it now, we are going to have 600.6. It means that our T2 here is 600.6 Newton. Okay, now this is the value of the both tension T1. Okay, we have the one of T1. Of course, it was this 503.195, and we also obtained one of T2 600.6 Newton. Okay, I think at this point I can end this teaching. All the best. Please don't fail to subscribe to my YouTube channel, Mathematics Science Mega Tutorial, and also don't fail to like my Facebook page, JB Jumbo Online Mathematics. All the best.